Hi guys, welcome to today's lesson 5.3 Slope-Intercept form continued. Today we are going to continue learning about slope-intercept form. There are so many different levels of slope-intercept form, and that we've only just touched the beginning of linear equations, but today we're going to dig into it a little bit more to find out and write the equations in slope-intercept form when we are not directly given the slope or the y-intercept. We can still find y equals mx plus b when I don't know what m is or I don't know what b is. But we can always figure it out. And today that's going to be using two different points. We're using a point and a slope. So this will be an x and a y, and then another x and a y. And this will be an x and a y and a slope. All right? Before we do that, we're going to warm up with some warm-up problems. So let me change this. Which ordered pair is a solution to the equation? Here I give you two ordered pairs, -3, 3, and -2, 2. I want to know if are both of them a solution, are neither of them a solution, or are just one of them a solution. Remember, we can find the solution to an equation by plugging it in and solving, doing PEMDAS. We have an x and a y, and we can plug this in for x and this in for y. If I do it and I solve it correctly, if it is a solution, this number will always equal this number, or my y will equal my x. That means it is a solution. If I get this number equaling a different number, or y equaling some different number, then that means it's not a solution. So it would not be on the line. A solution, so if I have, let's pretend that this is my line, y equals 4x plus 9. A solution means that it would be a point on the line. So if I solved it, I plugged both x and y in and they equaled each other, it would be a point on the line. If I solved it and x and y did not equal each other, that means it would be somewhere a point that's somewhere not on the line. So right now, what I would like you to try to do is to take a few minutes to plug in x and y and see whether -3, 3 is the solution, -2, 2 is a solution, are they both a solution, or are neither of them a solution? Do this now. If you haven't finished, go ahead and pause the video to finish. I want you trying this on your own. If you don't, that's your decision. If you're deciding, oh, I'll just wait till she gives the answer, there's nothing really I can do about it, but that's your decision and that's your motivation. And unfortunately, we see where people who are motivated and want to do things for themselves, where they go in life, and people who just don't, where they go in life. So we'll see what happens. If you have not finished, go ahead and pause the video now to finish. Otherwise, I am going to continue. So let's look at -3, 3. This is my x and this is my y. So I'm going to plug this in as 3 equals 4 times -3 plus 9. And I'm going to solve. 3 equals -12 plus 9, and 3 equals -3. So, is this a solution? No. Because 3 does not equal -3. They are not the same answers. Let's keep looking. Let's look at negative 2, comma 2. I know this is x and this is y. So I'm going to plug in 2 equals 4 times negative 2 plus 9. Let's look. 2 equals negative 8 plus 9. Negative 8 plus 9 is 1. 2 does not equal 1, so this is neither a solution. So we know it's not A, we know it's not B, it's definitely not both of them, so we know that it is D. Neither of them are a solution. If I had the line 4x plus 9, neither of those 2 points would be on the graph. Let us continue. I want to know the same thing. Which ordered pair is a solution of the equation? Now you might be looking at this and saying, but Miss Giambi, this isn't slope-intercept form. This isn't y equals mx plus b. That's okay. Remember, I told you in order for it to be a linear equation, there has to be one x and one y. So no, it's not in slope-intercept form. But we still can figure out if a point is a solution by plugging it in. It doesn't matter where the x or the y is. This is x, this is y. This is x, this is y. So just like we did in the last one, we're going to plug that in for x and that in for y. If when I solve them it equals 18, then it's a solution. If when I solve them it equals something other than 18, it's not a solution. So go ahead and pause the video again. Try this now. Pause the video and try this now. If you haven't paused the video, I am going to continue. This is x, this is y. So I'm going to say 5 times 5 minus 2 times y, oops, not y, 2 times 3 equals 18. 5 times 5 is 25, minus 6 equals 18. 25 minus 6 is actually 19. It does not equal 18. So this one's not a solution. Let's check for point 1, or 4 comma 1, x and y. So I get 5 times 4 minus 2 times 1 equals 18. 20 minus 2 equals 18. 18 equals 18. Yes, this is a solution. So we have 4 comma 1 is a solution. This is not written in slope-intercept form. That's okay, but if it were, which we'll learn later again, how to rewrite something in slope-intercept form, this would be a point on the line. Okay, so this next question says to complete the missing value in the solution to the equation. I would like you to think about how might you do this first. Pause the video again and see what might you do before you get the answer. I want you thinking, okay? Sure, you can play it and listen to my answer in a minute, but I want you thinking, what could you do to find the answer? Complete the missing value in the solution to the equation. Pause it and try this. Let's walk through it. I know this is x and this is y. If I want to find what x is, and I have an equation, it says this is a solution to the equation. So I know that this point does in fact fit into this equation. It is a solution. I don't know what x is, but I do know what y is. So I'm going to plug in y. So I have 4x plus, but instead of y, I'm going to say negative 6 equals 10. Okay, some of you might like writing this as 4x minus 6 because plus negative is the same as a minus. Now wait a minute. This is something we have seen before. When I have an equation, two sides, there's an equal sign, and I have one variable, I can solve for this variable. I want to get x by itself. In order to get x by itself, I first have to get rid of the constant. I get rid of what is not directly touching it. I add 6, the opposite, the inverse operation, and I have to do it to both sides. I get 4x equaling 16. Now, in order to get x by itself, this is 4 times x, so I need to divide by 4. This is x equals, well, 16 divided by 4 is 4. So now I figured out what x is. So I can tell you that actually the solution to the equation is 4, negative 6. Let's recap how we did that. We did that. We knew it was a solution to the equation. We knew it fit into the equation. So, and even though this isn't written in slope-intercept form, it doesn't matter. It has one x and one y. That's all we need, one x and one y, to make a linear equation. Okay, so we already know this is a linear equation. We're trying to expand our knowledge here a little bit. And we can find the solution to the equation, the missing value that we don't know, by plugging in what we do know. We did know y was negative 6, so I plugged that in and I solved for x to find that the solution to the equation was positive 4, negative 6. So that was our brief review, and you'll see why we did that review as we go through the rest of the lesson. Again, just to recap, today we're going to be writing and finding the equation in slope-intercept form, but this time when we're not necessarily given all the information that we need, like the slope or the y-intercept, we're going to actually find it. We're going to find it between 2 points, learn how to write an equation when we're just given 2 points, and we're going to learn how to write an equation when I'm given just 1 point and the slope. So we're going to start by reviewing the variables of an equation in slope-intercept form. We have y equals mx plus b. Remember that y is our dependent variable. Dependent. I'm rewriting that. Dependent variable. It is, in our point, the y. We always say it's our total something. Okay? We also know that our x is our independent variable. This is a review from everything we've talked about and from 4.3a. This is my independent variable. It is the x of the x comma y point, and this is always our number of something in a real world context. We also have, let's choose a green, m. M is my slope. It is my rate of change. It is my rate of change. Okay, in a real world problem, we can always find it by either it says rate or it says the word per. And that's why it's with our independent variable, because it's something per number of. And then last but not least, we have, my colors aren't working apparently. That's okay. Our b. Our b is our constant. And notice how I included the plus sign there, because that determines the sign of our b. If it's plus, it's positive. If it's minus, it's negative. This is our constant. We also like to call it our starting point in a real world equation. It is our y-intercept. It is where the line crosses the y-axis. And we always rewrite it as the point 0, comma, b, because x is 0 when we have a graph and the line crosses the y-axis. The line, I always draw that line, but the line could really look like that too. It could look like anything. So let's continue. One last little review. Let's see if this is going to let me. There we go. It's letting me change it now. One last little review before we move on. Here we have our XY point. Remember, these are solutions to the equation. It's any point on the line. Okay, we have multiples of those. There's these points, x comma y, everywhere. I mean, even in between the ones I'm drawing, there's an infinite number of points. Our m is our slope. That is the steepness of our line. Remember, we have positive slope, negative slope, zero slope, and undefined slope. A positive slope goes up, increasing. A negative slope goes down, it's decreasing. A zero slope is a horizontal line. It's neither increasing nor decreasing. And our undefined slope is one that doesn't technically exist in the real world, but it can happen on paper. That is our steepness of our line. It is our slope. It is our rate of change. That's where it is on the line. It is our change in y over the change in x. We also sometimes call that delta y over delta x, so you don't always have to write that a million times. Last but not least, we have our y-intercept, and it is where the line crosses the y-axis. And why does that help us? Because that tells us usually our starting point. In a real world problem, it's your constant, it's where you start. One more time, just to be repetitive, we have y equals mx plus b. M is the coefficient, the rate of change, the slope, the growth. B is where the line crosses the y-axis, our y-intercept, 0, b. Hopefully I've pushed this in your brain enough now that you dream about it. I'm sorry, I would never actually wish dreaming about slope-intercept form on you. That would be awful. But hopefully you at least could recite it in your sleep if you needed to. Okay, let's get on with our lesson. Again, we're going to look at something we've done before, believe it or not, right? It's a pattern I have. Everything I do is trying to set you up, trying to get it easy for you so it doesn't feel like you're constantly learning something new. So let's look at something we've done before. After a huge snowstorm, because in Wisconsin, where I'm from, we have massive snowstorms. A plow came through. Plows are those big trucks that shovel all the snow on the road. And it made a pile of snow that was 9 feet high. What happens is when they go and they plow through the road, here's the road, and they plow through the snow, what happens is all that snow goes off to the side, even in a parking lot, if it was a parking lot. And all of that snow just gets piled up along the side. And so they end up having these piles that are massive. Actually, it's funny, even when I was working at this restaurant, we had this massive pile, and it was summertime, and the pile was still almost gone. We had put bets on how long it would take because they're so huge, and then they freeze, and they turn into ice, whatever. Anyways, back to math. So it made a pile of snow that was 9 feet high as this plow went through the parking lot. After the snowstorm, there was sunny days, and every day the snow pile melted by 1/3 of a foot. So I'd like you to picture this right now. Here you have a parking lot, and here is a big pile of snow. Okay? And then the sun comes out, and every day, every single day, after one day, you lose 1/3 of a foot. After another day, you lose 1/3 of a foot. After another day, and another day, and another day, and another day. Okay? Is the pile of snow increasing or decreasing? It's decreasing. It is decreasing. It's going down, which actually tells me my rate is decreasing. It's negative, which tells me my slope is going to be negative. So let's look at this. Maybe I'm going to leave that, actually. Write an equation in slope-intercept form to represent this scenario. Well, we know we need a y, which is our total something. We need an x, which is our number of something. We need an m, which is our rate, our slope, and we need a b, which is our starting point. This is our recipe. If you don't remember the recipe, go back and look. Where are we starting? We're starting at 9 feet of snow, and I'm actually going to rewrite it like that. Our starting point is at 9 feet, okay? And then we have our rate. Our rate is melting by 1/3 of a foot per day. So minus 1/3. Okay? Minus 1/3. Now we have our x, which I want you to define because we have to do it anyways right here. Actually, we'll wait to do that. Let's look. We're going to rewrite this then as we know our starting point is our b, our y-intercept, and our rate is our m. We need to write this as y equals mx plus b. So it's y equals negative 1/3 x plus 9. This means you're losing 1/3 foot per day, but you're starting with the 9 feet. We're going to define the variables of this equation. So what does y mean? This is what I mean when I'm asking for defining the variables. Y is our total what? It's our total height of the snow pile. Y is our total height of the snow pile. What is x going to represent? The number of days. Number of days. Now, just a little side point. Remember, our b is 9, which means it's 0, 9. Take a look. If x is number of days and y is total height, that's what that y-intercept means. After 0 days, your pile is 9 feet tall. 0 days, that's our starting point. Okay, we know m is our melts. I guess we don't need to put negative if we're putting melts. Melts 1/3 feet per day. That's our slope. And our b is starts at 9 feet. When I say define the variables, this is what I mean. Okay, if nothing changes, how many days does it take for the whole pile to melt? Let me add a page in here because apparently I've ran out of room. So, if nothing changes, how many days does it take for the whole pile to melt? Now, just a little piece of advice. If you had to make an equation in one of your problems, you're going to have to use that equation when I ask you something. You're never going to have to rewrite an equation or do any addition or whatever in your head. You're going to use the equation. I know my equation is y equals negative 1/3 x plus 9. That's my equation. So it says, if nothing changes, how many days does it take for the whole pile to melt? Remember, we have x and y. X is number of days, and y is total height. This one we have to look, because this isn't saying After how many days will the pile be 1 feet? After how many days, whatever. This is saying, will the whole pile melt? So I need to decide, which one am I given? Am I given X or am I given Y? Do I know number of days? No, because that's what it's asking me. It's asking me, I don't know the number of days. But it's saying the whole pile to melt. Do I know the total height? Well, how high would the pile be if it was all melted? 0. 0 feet. It would be at 0 feet. If the whole pile was melted, it would be at 0 feet. So let's fill this out. Let's look. If nothing changes, how many days would it take? This is just like this problem that we did. I know one of the numbers and I don't know the other. We've done this before too. Plug in what we know to find out what we don't know. I'm going to plug in 0 for Y to find out what X equals. So let's look. I'm going to say 0 equals negative 1/3 X plus 9. Let's solve that. I'm going to draw my 2 lines down. If I'm trying to get X by itself, the first thing I need to do is get rid of the constant. I'm going to subtract 9, subtract 9. That's going to get rid of it completely on this side and move it to the other side. 0 minus 9 is negative 9. I'm left with negative 1/3 X. Now, remember, ladies and gentlemen, how do I get rid of a fraction coefficient? Multiply by the reciprocal. What is the reciprocal? It's the flipped fraction. In order to get rid of it, we multiply by the reciprocal. So I have negative 9 equals negative 1/3 X. I'm going to multiply by 3 over 1, but I need to also have a negative. And I need to do that on both sides. I can put that over a 1. Hopefully you remember that. Getting rid of a fraction coefficient, we multiply by the reciprocal. Because it's going to make it 1. Take a look. Negative 1 times 3 is negative 3. 3 times negative 1 is negative 3. Negative 3 over negative 3 is actually 1. So that's how we get X by itself. Here I have 3 times negative 9, which is negative 27, and negative 1 times 1, which is negative 1. A negative divided by a negative is a positive, so I have 27 over 1, which is the same as 27. So what does this mean? My X is 27. This means that I have 27, 0. This means that after 27 days, the whole pile will be melted. There'll be 0 feet of snow. So we've done this before. We make an equation, we plug in what we know to find out what is missing. So let's look at this from another perspective. And can we reach the same conclusion? Let's look. After having a huge snowstorm, a plow came and cleared a parking lot of snow. I'm going to add another page actually before I finish reading this. Okay. After having a huge snowstorm, a plow came and cleared the parking lot of snow. It made a pile of snow that is very high. This is the difference. It doesn't tell us how high the snow is. After the snowstorm came sunny days. Every day, the snow pile melted by 1/3 of a foot. After 6 days, there was 7 feet of snow. Do you see the difference between this one and the last one? The last one told me my rate and my starting point. What is this one giving me? Let's look. Let's look at the information that I have. I know that I need a rate. I know that I need a starting point. So let's look at what I'm given. And I know that I'm going to have x being my number of something, y being my total something. So we're going to see what we have. Do I have a rate? Is it actually, let's start with starting point, sorry. Do I have a starting point? Is it telling me how high the pile is? After having a huge snowstorm, a plow came and cleared a parking lot of snow. It made a pile of snow that was very high. Is that a number? No. So we don't know our starting point. Every day the snow pile melted by 1/3 of a foot. Well, that's a piece of information. Which one is that? My rate, my x, or my y? My rate. It's 1/3, but be careful, it's melted. So it's -1/3. So at least we know our rate. Now let's look at what we're given. After 6 days, there was 7 feet of snow. X was our number of days. Y was our total snow. So I know number of days. We had 6 days that there was 7 feet of snow. Let's look at what I'm given. I'm given 3 pieces of information. I'm not given my starting point. These two, after 6 days, I'm given 7. I have 7 total feet of snow. Those two are a point. An x, y point. I know it's going to be y equals mx plus b. Let's plug in what we know. I know y is 7. I know m is -1/3. I know x is 6. I do not know b. All I did was plug in the information that I found. But take a look, guys. I have an equation with just one missing variable. I can solve for b. I have 7 equals. Let's look. You can either put it over 1 and multiply, or you can do my trick. 6 divided by 3 is 2, times -1 is -2, plus b. And if you need to make it a capital B so you don't make it a 6, that's great, do that. How do I get b by itself? I add 2, I get 9 equaling b. Now I know my m. I already knew that, but now I know my b. All I need to do is plug it in. Y equals mx plus b. Y equals -1/3 x plus 9. Now notice, in my final answer, I did not plug in x and y. I did not plug in numbers for x and y. That's because we need to have those blank as x and y. The only reason I plugged them in here was to solve for my missing variable. That's what that gave me. So this told me 1 point on the line and my slope. By knowing that, I'm able to calculate by plugging it in and find my y-intercept. So let's look. First, I think I missed a slide. That's okay. Let's look. What we want to do, we already talked about this before, so don't worry about that. We always want to, we'll just put this here. The first thing we do when I'm given a problem, a word problem or whatever, is define my variables. We want to know What do I have? What am I missing? So that's what we did right here. We identified what we had and what we were missing. You're always going to put M, B, X, Y to identify which ones do you have, which ones do you not have. You really should only be missing one, whether it's your M or your B. You're missing something. And actually, I take that back because sometimes you'll be missing both. We'll get to that in a minute. But you really should only be missing, in this case, one. And once you can figure out what you have and what you're missing, then you're going to ask yourself, how can I use what I have to find what I need? So when we found out we had M, B, X, and Y, when we knew M was -1/3, we didn't know B, we knew X was 6, we knew Y was 7. How can I use what I have to find out what I need? By let's see, Y equals MX plus B. We can plug in what we have to find out what we need. So lastly, we write our final equation. So you only plug in the slope and the y-intercept. You never plug in the x and the values for x and y. It should always be y equals some number, x plus or minus some number. Those always are numbers. Your x and y are always x and y. So our final answer was y equals -1/3 x plus 9. This is right. It would be wrong if I had put 7 equals -1/3 6 plus 9, because that was what our x and y was. This is wrong. It's x and y. We only use that x and y numbers to help us find what we're missing. So let's try a couple problems together, okay? Let's see where we're going here. Okay, let's try a couple problems together. An underground gasoline storage tank was being filled at a rate of 5 gallons per minute. So here you have the gasoline tank, okay? And it's filling up at 5 gallons per minute, okay? After 7 minutes, 47 gallons were filled. Oh, I should be writing this. 5 gallons per minute. After 7 minutes, 47 gallons were filled. I wrote our 3 steps here to help us. We need to write an equation in slope-intercept form to represent the scenario. So the first thing we need to do is to identify what do we have and what do we need. So do we have a slope, a y-intercept, an x, or a y? Do I have a rate, a slope? Well, it says was being refilled at a rate of 5 gallons per minute. And is it increasing or decreasing? It's increasing. So we know it's 5 gallons per 1 minute, which is the same as 5. So we know our M is 5. We have M. B, our starting point. Does it tell us anywhere how much the tank starts with? Because we don't know if it's starting at completely empty, at 0. We don't know if our tank is completely empty when they start filling it. It shouldn't be. That wouldn't be smart for a gas station to wait until its gas tank is completely empty. So it doesn't tell us where it starts. But it does tell us that after 7 minutes, 47 gallons were filled. Well, in this problem, X is going to be the number of, and Y is my total. Number of minutes, total gallons. So let's look. I know after 7 minutes, so X is 7, there was 47 gallons. Y is 47. That makes the point 7, 47. If I'm trying to make Y equals mx plus b, we're going to plug in what we know to solve for what we don't have. I know m is 5, so I'm going to plug that in there. I don't know b. I know x is 7, and I know that y is 47. Once I plug all of those in, 47 equals 5 times 7 plus b. Once I plug all of those in, I can solve for b because it's the only variable I'm missing. So I get 47 equaling 35 plus b. Then I'm going to get b all by itself by subtracting 35, subtracting 35. And so, let's look. What is 47 minus 35? 12. So I know 12 equals b. Now I have an m. Oh, I put b equals b. 12 equals b. Now I have an m and a b. So instead of y equals mx plus b, I'm going to say y equals 5x plus 12. So this means my tank started with 12 gallons in it. It wasn't at 0. It had 12 gallons left, and I was going to fill it at 5 gallons per minute. My next question for you is, if the tank can hold, let's put in the number, 400 gallons of gas, how many minutes does it take to fill the tank? Okay, like I've said before, if we just made an equation, you are going to use that equation. I know X is number of minutes, and I know Y is total gallons. What am I given? If it can hold 400 gallons, that's Y. So I'm going to look for X. So I'm going to plug in 400 because we know Y is 400. We don't know X. We're going to plug in what we know to find out what we're missing. Equals 5x plus 12. And let's solve. To get x by itself, I subtract 12, subtract 12. 400 minus 12 is 388. That equals 5x. We're going to divide by 5, and 388 divided by 5, do it on your calculator. I don't care if you do it on your calculator. That equals 77.6. So, if the tank can hold 400 gallons, it takes 776 minutes to fill it 400 gallons. Now, you might be saying, but there was already 12 gallons in it. But we already took that into account when we solved. When we subtracted 12, we subtracted the 12 gallons that were already in it. So that meant we needed to fill it 388 more gallons. So that's how we solved that problem. Here's what we're going to do. I'm actually going to have you guys... Nope, we're going to keep going. We're going to keep going because we're almost done, rather than have you guys do more. Let's try one last one. Be vigilant, though, because this one's a little bit different. Salem was boiling water at a constant rate. After 2 minutes, the water was 18 degrees. And after 4 minutes, the water was 34 degrees. Write an equation in slope-intercept form to represent this equation. Okay, let's look. We need to find what information we have, what information we don't have. My x is the number of minutes. Y is my total degrees. Okay? So, M, my rate. Does it tell me what rate my water is boiling? It just says a constant rate. Okay, so we don't know that. It says after 2 minutes, the water was 18 degrees. And then after 4 minutes, the water was 34 degrees. Does that tell me how much the water started with? The degrees? No. Uh-oh. What am I given? This means after 2 minutes, it's 18. This means after 4 minutes, it's 34. I'm given 2 points. I'm given 2 points in this one. So, I have the point 2, 18 and the point 4, 34. That's step 1. We know what we have. We know what we need. We need M and we need B. How can I use what I have to find what I need? Well, do I know how to find slope between 2 points? 4.2 y2 minus y1 over x2 minus x1. We have to make one x1, y1, x2, y2. We plug it in. 34 minus 18. 4 minus 2. 34 minus 18 is 16. And then 4 minus 2 is 2, which I can divide both by 2 and get 8 over 1, which equals 8. So I know that my slope is 8. This is just like what we did on the practice you guys did with the table. You were given 2 points, you have to find the slope. And then a lot of you always ask me, but what if I don't know my B? Well, now we can go back to what we just did, because now I know my M is 8, and I have 2 points. I have an X and a Y and another X and a Y. Choose one to plug in. And you know I have Y equals MX plus B. Now I know that I have M is 8, and you have an X and a Y here, or an X and a Y here. Plug in any of the 2 points. I'm going to choose 218 because to me it seems like easier numbers to plug in. This is my X, this is my Y. So I'm going to plug in 18 for Y, 2 for X, and now I solve for B. I get 18 equals 16 plus B minus 16 minus 16. I get 2 equals B. So last but not least, I need to take these 2 pieces of information and plug it into Y equals MX plus B. Y equals 8X plus 2. We will be going through this more next class, so don't worry. I know it's a lot of information. I'm almost finished, though. So let's get this straight. We know slope-intercept form is y equals mx plus b. So we can be given the slope and the y-intercept. This is the easiest one. This is what we did. This is 4.3a. Okay? It's really simple. All we do is plug in m and b into y equals mx plus b. That was 4.3a. That was the simple one. Okay? This is 4.3b. Okay? If I'm given the slope and a point, x comma y. The first thing we do, so this is if I'm missing my b, if I don't know my b. First thing we do is plug m, x, and y into y equals mx plus b. Second thing we do is then we solve for b. And the third thing we do is we plug only m and b into y equals mx plus b. Last but not least, we have if you're just given 2 points, xy, xy. So this is if you're missing m and b. The first thing you do is you find the slope between the 2 points, which we use y2 minus y1 over x2 minus x1. Second, we plug in m, our newly found m, and one of the x, y points. You choose one of the two, any one, because you have 2 points. You just choose one of them. Then you solve for b, and you plug m and b only into y equals mx plus b. Whew! I'm exhausted. I don't know about you, but I'm exhausted. This is a really important page, ladies and gentlemen. You need to have this page because this page gives you step-by-step instructions for all 3 possibilities. Another really important page is this flow chart I made for you. If you're still struggling, use this flow chart. This is where you start. Here and here. You ask the question and you answer it. So, are you given a slope? When you look at your 2 points, okay, or you look at your information, ask yourself, are you given a slope? Yes or no? If you are given a slope, then that is your m. Wonderful. If you're not given a slope, do you have 2 points? No, if you don't have 2 points, then there's not enough information to make an equation. But if you do have 2 points, you use the slope equation, y2 minus y1 over x2 minus x1, to find the slope between the 2 points. And now that is your m. Next, are you given a y-intercept, a b? If yes, then that's your b. If no, follow the steps. Are you given 1 point? Yes. Plug it in and solve for b. If you're not given 1 point, are you given 2 points? Yes. Pick one of the points. So do you see? I hope you see how this works. You follow the flow chart. Try this. You are going to try this with your exit slip. I give you the steps right here. You may use your flow chart, okay? So this one is through a point X and Y, and I give you slope. So this one you're given slope, but not the y-intercept. So you're going to have to plug in what you know to y equals mx plus b, or plug in what you're given to solve for what you're not to write the final equation. This one, I'm giving you 2 points. So this one, you do not have m or b. You need to plug those in and solve for that. So do this exit slip, turn it into teams, and we will definitely be reviewing this next class. Don't you worry. We will absolutely be going through it quite a bit, but try these two, please, and submit that. I hope you have an absolutely wonderful day. Thank you for listening. I miss you all, and I appreciate